Hello there, good people. Welcome back to part 2 of our live stream. This is the return of the Wi-Fi. So I believe it or not, the stream status is excellent. The stream is healthy. We're getting good data through. Here we are. Again, I'll just hang on for a few more people to join us. And then we'll get stuck in to some revision. Hello to the people in the chat. Hopefully our regulars join us from the last session as well. For those people that missed the first live stream, don't worry, it's all uploaded. I still need to timestamp it though, but I'll get round to doing that shortly. This is revision for paper 1, but be careful, I don't know what exam board you're looking at, because this is the Educast WJEC exam board. Excellent. You can always watch this after you've seen Doctor Strange, don't worry, it all gets recorded. Yeah, there's a lot of crossover to Cambridge, Cambridge Technicals. But this, again, this is Educast, this is WJEC, so this is a different specification. Pseudocode for 2D arrays. If we get a chance at the end, we can look at that. So let's have a go. Let's get stuck in then. So this is where we were left last time. We were left on these areas to revise. We started to pick up the algorithms and programs section of our specification. And the amplification materials say that we've got parameters and programming constructs to look at. So we jumped in to looking at our different types of parameters. So a parameter, don't forget, is just whatever is inside the brackets of our subroutines. And a subroutine can be a procedure or a function. So parameters are used to pass values into subroutines, and it's usually used instead of using global variables, because we want to try and reduce global variables because of the memory usage and also for the security of using global variables. We always try to use local variables, and to pass data around we have two types of parameter passing. We have something that's called by reference and something that's called by value. So you might have checked the end of the live stream, and this is where we left off really, just after an exam question. My Wi-Fi died. So if you pass data by reference, then what you're doing is you are passing a copy of the memory address into the procedure. Okay, so if you pass a copy of the data into the procedure, then because you pass the actual memory address itself, then you can change it in its original location in random access memory. Okay? The default way of doing it now is we pass by value. So what that is that actually creates a copy. It doesn't pass the memory address, it just takes the copy and passes that. And then you can use it for whatever you need to. You can display it, you can use it for different types of arithmetic calculations, and then it gets destroyed. So it's a copy. You can't edit it in its original location, so it's much safer, and that's why we tend to use by value. So for example, if I show you here, this is a subroutine, and whatever is inside the brackets, this is the parameter here. Okay? Now we don't know if that's by reference or by value, but we have to look at questions like this in order to work it out. Now again, if you've got questions, do stick them in the chat. I will do my best to get to it. But I can't always see the chat, so there we are. So here we've got a typical exam question looking at parameter passing. It says explain why it is good programming practice to use constants, meaningful names for variables, and annotation. Well, a constant is something that doesn't change throughout the life of the program. So for example, pi, that value shouldn't change throughout the life of the program. So that's a constant. Now the problem with constants is that they take up memory for the entire life of the program. But the benefits of that is that once you change pi's value when the program stopped, wherever you've named pi, it will change that everywhere in your algorithm. So that's a bonus. Meaningful names are classed as self-documenting identifiers. What that means is whatever the variable does or whatever it's holding, it's named after. So for example, total score, if a variable is called total score, then you know it's going to hold the total score. And that is a good self-documenting identifier or a meaningful name. And then we have annotation. So annotation is this in our algorithm is annotation, which basically just explains in plain terms, simplistic plain terms, exactly what the algorithm is doing. Now the reason why we use annotation is for other developers normally, or if we don't use the code for a long period of time, coming back to it, often it takes a little bit of time for us to get our head around it. So what we do is we read the actual comments just for it to explain what that section of code is doing. And that helps us with our readability and understanding much more. Now in addition to this, we have from the above algorithm, identify the value and the reference parameter. Okay? So reference, remember that is the address. So we're passing the address, and that means that variable can actually change. Value is a copy. So in this algorithm here, first identify the parameters. Well, I said to you, parameters are variables inside the parentheses really. So here you've got your subroutine, which is called find area, because it says declare subroutine find area, and it says R and A. So R and A are parameters. So one of them or both of them might be a value, and both of them or one of them might be a reference parameter. So I need to look through my code and work out where these things are actually being used or not. So if I just get rid of these so we can see a bit clearer. Here, pi, it's not being used there. Start procedure, not being used there. Set A equals pi multiplied by R multiplied by R. Now A is being used here. And what's happening is it's being assigned a value. So what's happening there is we're taking the result of this calculation and putting it inside the A variable. So we're actually changing the A variable there. We're taking 3.142, which is pi, multiplying it by whatever R is and whatever R is there. So R is our parameter up there. So because we're changing A, we know that reference parameters are changed because we passed the original memory address in there. So A would be your reference parameter, and R, because we're only using it as a part of the calculation and we're not altering the value of R, that therefore it is a value parameter, and that gets you 1 mark. Then it says explain the difference between a value and a reference parameter, giving an advantage of using a value parameter for 3 marks. So 1 mark for explaining the difference between value and between reference, there's 2 marks in total, and then give 1 advantage of using a value parameter, that's 3. So remember, value parameters, we have a copy of the data that gets passed into the procedure, and that cannot be altered, that's 1 mark. And that has the advantage of avoiding unwanted side effects like people editing or people changing the value by mistake. So there's your advantage for 1 mark. And then we've got a procedure, a reference parameter. That is where the memory address is passed in to the procedure, and that means that the data, wherever it's being called, wherever it's being used, can be altered. So in total, that's our 3 marks. And if we check the mark scheme here, you can see we've got value. So that's 1 mark for your value, 1 mark for your advantage, and 1 mark for your reference. Okay. just reading the chat. Systems analysis. Yeah, we get to systems analysis and expert systems. That is on our exam. Now then, as we move forward, we need to look at programming constructs. So there are three main types of programming constructs. These are the foundation or the fundamentals of all programming, and every single language you come across, no matter what it is or what it's for, it will use programming constructs. There is sequence. That means things going in an order one after another. There is selection, which is typical, it's if statements. And then we have iteration, and that's repetition or looping. Often, students get caught out because they're not used to the formal terms and the informal terms. So sequence is a formal term, selection is a formal term, and iteration or repetition is a formal term. I like to say, when I communicate, I'll just say iteration, or I'll just refer to it as looping, and then if statements if I'm talking about selection. So be careful not to get caught out here between the different terms that we use. So if I ever refer to selection, I'm talking about if statements. If I ever refer to iteration, I'm talking about looping. Okay? So what I've done is I've got some code for you, and I can show you where sequence is actually occurring here. So if you look at this code here, you might be asked to explain where sequence is going on. Now, sequence is where code starts from the top and it flows in order. So first we look at the public class TFGM, Travel for Greater Manchester, and then we have a variable being declared. This is Visual Basic, by the way, .NET. And you have a variable being declared. So declare this variable called number of trams as an integer, and then you've got regularity of trams, single, and number of staff as an integer, and number of routes as an integer. Now the code will execute this and create the variable, execute this line, create the variable, execute this line, create the variable, and execute this line and create the variable. It will go in order, one after another, in sequence. That was good. Now, oh, this touchpad. Oh, there we go. Oh, no. Okay. Then we get down to the private sub. If this is called, so when the form loads itself, it triggers this action. So this is an event that's being created. So when you load the form, you go into run line 8, then run line 9, then run line 10 and line 11. These are asking questions to the user and taking in an input along the way. So on your screen, a box will pop up and it'll say how many trams are in operation. The user types something in and that gets assigned into the variable. Same on line 9, same on line 10 and same on line 11. Then we end on line 12 and end the class on line 13 and we are done. So that's sequence, when things flow one after another. The next one, we have selection. So selection is obviously if statements, and you might be very used to these already. I put two different types in here, or well, I'll show you two different types of selection, and you can spot selection simply by the keyword if. They have else parts to them and they end the if. Okay, so it's if and then a condition. So our condition here is age is greater than or equal to 17. Then we've got a logical operator, and then we've got age, or a logical condition, then we've got age is less than or equal to 70. Now these things here with these ands, logical conditions, we can have and, we can have or, and we can have nots. They are our three logic conditions that we can have. And in this one, with an and statement, both statements need to be true in order for us to do the true part of the statement. So if our age is greater than or equal to 17 and our age is less than or equal to 70, then we will pass this entire condition and we will run this line here. And it will output this message, valid conditions entered, name, you may do your test. Now if it fails that condition, it will do the false part, which is after the else. So if it fails, do the false part and then run this message box instead. So selection allows you to branch through your code. Now not only do we have true and false parts, we can extend our selection statements by having if this condition is true, carry out this part, else if, add another condition in there, a second condition, So if it fails the first one, if we're not 37, then we go to else if, and it says if else is greater than 37, then we output the message box too high. And then if we fail both of these conditions, so if we fail this one and we fail that one, then do this part here, because this is the else. So you can have as many else ifs as you like and as many conditions in there alongside it. Now, the only other thing to talk about with selection statements is nested selection. Now remember, this is AS level. So GCSE level, we'll just talk about standard selection. Now we're at A levels and ASs, we're talking a little bit more technical about nested selection. So nested selection occurs when you have an if statement embedded within an if statement. So here, there is no evidence of nested selection. This is a standard if statement. On this one here, you have an if statement that goes all the way to the bottom here, and you have a true part, another condition here, a true part for that second condition, and then you have another true part for this third condition, and then you'll see another if statement in here. Now that has been indented to show that it is nested. This if statement is inside this if statement. Okay? You can have as many nested if statements as you like. You could say, well, I've got if, and then an if, and then an if, and then an if statement, and an if statement. You can keep going forever if you wanted to. Now obviously, the more if statements that are nested, the more complex it is to read. So you've got to be careful. You've got to try and simplify your logic as much as possible. Just reading the chat. All formal terms. Hello, Kevin. Now then, the next one we're talking about is iteration or looping. So basically, you've got iteration here. In different languages, you have different types of iteration. So this is a preconditioned loop. And a preconditioned loop, I'll just write that out. Precondition means the terminating condition comes first. There we go. There's your terminating condition. So in a for loop, it is also static. So for will give you an exact number of iterations unless you break out of it on purpose. So in here, it says any number is an integer. We put in a number and then we go up. It says for number equals 1 to 12. Okay, and then that multiplies. This is a times table program, so it'll loop exactly 12 times. It goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now you got to be careful here because coming from GCSE, Python people, with these loops it goes up to but not including 12. Okay, not in this language it doesn't. So this language will produce 12 iterations there. Okay. So iteration, you're just looking for loops. So for, sometimes we see do's, we see do whiles. These are all types of different iteration. We see repeats as well, repeat untils. You see all kinds. Do loop, do while, yeah, you see all of them. Lots of different types. In Python there's only 2 that we use. And it's for and do. Now nested iteration as well is exactly the same as selection in terms of it's the condition inside itself. So here we've got a for loop, as you can tell, and then indented for ease of reading, we've got another for loop in here. So this is where the nesting has happened, a for loop inside a for loop. So as this loops from 1 to the high number, every single one of these loops, you will get 12 inner loops. So this will loop once, run 12 times. This will loop again, 12 times. This loops the third time, 12 times. Fourth time, 12 times. Fifth time, 12 times. You get the point, okay? So nested iteration is a loop inside a loop. Okay, nice and simple. Now then, moving on from there, we have a next part which is all about scope, and there is two types of scope that you need to be aware of, and we have the first one which is local scope, and we have global scope. Now when we talk about scope, we're talking about the lifetime of the variable. So with local scope, these are local variables and they are only accessible by the subroutine they have been declared in. And remember, when I say subroutine, I'm talking about a procedure or a function. Okay? So if your local variable has been declared inside a subroutine, then it will only last as long as that subroutine lasts. With global scope, these are variables that are available to any subroutine throughout the program, so they can be accessed anywhere you like. Now, that's great because it can be accessed anywhere. The problem is it's going to hold that memory and RAM for the length of your entire program. And in computer science, we do say variables die, which they do. Die just means give up their memory. So local scope is great because they only hold memory temporarily. Global scope, length of the program. So my question for you now is, can anyone tell me, hopefully you can see those line numbers, can anyone tell me where I've declared global variables in there? Line numbers in the chat, please. Bit of user interaction. Hello, Sam. Does anyone know where the global variables are? Line number 10. We've got 5, 6, 7, 8, 10. So we're saying 5, 6, 7, 8, and 10. 5 and 10. Yeah. All these have all got very good programming teachers. Kevin will be proud. Excellent. So can people tell me where the local variables are? So these are all global, declared at the top of the program, outside of the subroutines. So here's a subroutine. (14) and 15. So you're saying these two here. Are there any more? Nope, that's it. Perfect. 14 and 15. So these are declared within our subroutine, and these are local to our subroutine, and these ones up here, these are global. Don't ask me about that program. It's talking about hot dogs. Oh yeah, that's my password if anyone wants it there. Perfect. It's good security, isn't it? I'm joking. It's really not. Perfect. Good. Now, one other question that you could be asked is about structure. So what are we talking about when we're talking about coding structure? So this is something that you may not have been told about in your lessons, but you will intuitively do or have been trained from day one. All of your programming teachers will teach you the structure and the things and how to write in the coding language that you're looking at. And we're talking about self-documenting identifiers. So remember, these are normally done or normally created to help other developers working on different parts of the program. We normally decide on our naming convention before we even code. And that's only because we're working with other developers. And it's important to be consistent in what you're doing. So for example, setting a variable like total score, you know that's going to hold the total score. For example, total VAT, you know it's going to hold the total VAT. All right. So it's always good to name your variables after what's being stored inside them. Another thing to think about as well is annotation. Now, lots of programmers that I come across hate validation, not validation, annotation. They hate annotating their code and writing about their code, but it is incredibly useful, not only for me as a teacher, but for any other developer that's going to share or look at your code in order to work with you. Okay, it can be tedious, but it is very helpful. And normally you'll have a specific symbol for your language in order to denote that that is a comment, whether that's an apostrophe or 2 slashes or a hash symbol. And normally it changes colour as well. And it's important to talk about colour because colour is also a big one when it comes to structure. But your IDE, your integrated development environment, will automatically do that for you. Okay? And talking about this, we have indentation. So indentation is all about our indents, and you can see at the top of the code there, we have indentation. On the left-hand side, we have zero indentation, and it often becomes incredibly difficult to read. On the right-hand side, we include a little bit of indentation just to make it easier for us to read. Now, as you compile this, as your IDE turns it into machine code, during lexical analysis, it gets rid of all the white space. So it doesn't matter to the computer, it only matters to humans. Okay, now then. I don't know what Max is talking about. Oh, okay. So let's have a look at the question then. So programming languages use constructs to control the order in which commands are carried out. Describe the effect of the use of a selection construct. Okay, so the first thing I'd be talking about, just for this question, it's only worth 2 marks. Describe the effect of the use of a selection construct. Okay, so what I'd be talking about is talking about the fact that there is a logical condition. Now you have to have a logical condition in order to determine whether to carry out the true part of the statement or the false part of the statement. Now I would be really tempted in this question to just demonstrate what's going on. I'd say if condition, and then I put true there, else false, and if. Okay, then I could even go in to explain this and say if a condition is true, you carry out the true part of the statement. If it's not, an else is used and we carry out the false part of the statement. Simple as that. Okay, simple as that. And that would get me 2 marks. Then it says explain with reference to selection constructs. So again, we're talking about if statements here. What is meant by the term nested? And because I've done this in the first question, I'd be very tempted again to do this. Now I'd say if the condition, I might put condition 1 there this time. If condition 1 is true, carry out true part, else, and I could say else, carry out the false part, and have another if in there that carries out another condition. And again, I could have an else, true and false, and end if. And again, I'd be tempted to explain it. It's only worth 2 marks, so I don't need much explanation, but I've got one selection statement and I've got another one inside there which shows the if. Would help if I end my ifs properly. There we go. So there is my nesting there. And that would get me 2 marks in total. Okay. Now then, 3 more topics to go. So we're going to talk about principles of programming. Now, describe the distinguishing features of different types of programming. So, programming paradigms. A paradigm is essentially a style of writing code. We have lots of different formats and languages, etc., but different languages cover different programming paradigms. So we've got a couple of paradigms that we need to be aware of, such as procedural, event-driven, visual paradigms, and markup languages. There is another one in there as well called object-oriented, but that comes under your second paper. So that's inside your programming paper. And your programming tutor would explain that to you, and they'd be going through with you soon, or if not already, they will be going through object-oriented program with you as well. Right? I'm sure they'll comment in the chat whether they've done that or not. All right. So what we're going to do is look at. We're going to look at these now. These are very theoretical. There's no real programming element inside these, but we have to describe the distinguishing features of different types of programming paradigms, including procedural, event-driven, visual, markup languages. So you might have even used some of these before without even knowing, okay? But a programming paradigm is a fundamental structure and approach of a programming language, okay? So what are they used for then? Now they're used as a way to classify programming languages based on their features. And the main goal of all of these really is to try and help us write code and write it more efficiently as best as possible. And we use them for different scenarios. Now you don't get taught about programming paradigms at GCSE, you're just told to use a language and you just use the language. But as you grow as a computer scientist and you get older and you get more wise, you then would look at why I would use that language over using that language. And why would I approach this problem using that language rather than that language? So let's first start with some of these then. Now you'll see two more in there. So your object-oriented has been added on there as well, and non-procedural. Now we cover non-procedural, and that's only because it creeps in somewhere on a mark scheme. So I will gloss over, well, I will cover it just for ease of use. Right, so procedural paradigms, typical things like Python. Now when I say Python, some of these languages do multiple paradigms because they steal features from different paradigms. So these procedural, they are programs which run from start to end sequentially or in sequence, one after another. Yeah, remember one of our constructs, sequence, selection, iteration, in sequence, so one line after another. Okay, they start at the top of your code and they work their way down. Now the only way in which they change their direction is if we encounter something called a control statement, and that could be an if statement of some kind, which is selection, or it could be iteration, which is looping. They have a number of features, so they're made up of a few different things. They have your standard things that you see in programming, such as variable assignment, they'll have selection, they'll have iteration, they'll have modularity built in, and modularity is basically splitting things up and recombining them later. Okay, you might have heard of it referred to as decomposition, the breaking down of something and then recombining it when you've worked it out or problem solved it. So they're the different things that procedural paradigms have within them, typical of any language. Now your procedural paradigm, it also gets referred to as an imperative language around. So if you're in the industry, you might refer to it as an imperative language. And they use statements to change the state of a program. So different statements that you write will change what direction you go, change the state of variables, etc. And that can change throughout the life of the program at any time. Now we often start on procedural. So I don't know about you, but normally in secondary schools you'd start doing a little bit of Python in year 9 maybe and move your way up. Some schools do it in year 7 and some schools don't even teach any programming at all. But procedural is where we normally start out because it follows simple logic. So if it follows simple logic, then it must be easy to learn, right? Well, you'd think so, but it's not quite as straightforward as that. So let's look at some examples then. We've got languages like C and Python. Classic languages that start from the top and move their way down unless they reach a control statement. And that's really it for procedural. Things go in order, there is a procedure to them, they're very logical, that sort of stuff. Hello, what did I miss? I missed like 30 minutes. Yo, John, do you remember me? Oh, yes I do. I've just taught one of my classes. Oh, fantastic. There you go. Thanks, Kevin. just going to move this so I can see the chat at the same time. I need more screens, that's what I need. Now then, so procedural, very rigid, very ordered, usually text-based programming languages. Although the beginning languages, they're not massively fun. Yeah, you might have different experiences. So we're going to talk about visual programming. Okay, visual programming is normally for children. I'll say it like that. It's normally for children. And if you've ever seen that logo in the top corner, right, I cannot tell you my disdain for Scratch. We use it to get young people into programming because it's fun. However, I cannot stand Scratch. Apologies if you like it, but if you like it, I've lost a little bit of respect for you. So programmers usually start with visual programming languages, which is fine. They are intuitive, you can drag and drop. There is very simple. You can't break them. You cannot break them really. Okay? So you drag and drop things around, you can delete things, you can try and break it, and good luck to you. Alright? They are made to be robust. But the main thing about visual languages is that there is no massive focus on the syntax. You don't have to write things with brackets. You don't have to put speech marks. You don't have to be specific about the language syntax. So you can focus on the logic. You can focus on the type of blocks that you would put inside there. So that's the main thing for me, really. There is no need for learning complex syntax because young children cannot focus on syntax and getting things accurate. I mean, I teach first and second years and they still can't remember where semicolons go, where speech marks go, where brackets go, etc. So, you know, visual is the way to go. And there we go. We see, look at the IDE, look at the integrated development environment for Scratch. It's colourful, it looks exciting, there's characters. Normally, we spend 10 minutes normally in the second year using Scratch to try and build a program, and it's the lesson I hate the most of all lessons that I teach, because all you do is you hear students put an infinite loop with a cat meowing for about 10 minutes. It drives me insane. But with Scratch, you've got characters, you've got actions that are applied to them. There's a question in the chat there saying, is VB procedural? VB can be procedural, but it's mainly event driven, which we're going to get to in a minute. So it's triggered by users' events. But with visual, Scratch is a very good example of this. We've got dragging and dropping of blocks in there. We have event driven built in. So like I said, some languages will be combined. Now all languages that I've seen, I'll say most languages that I've seen that require user interaction will be an event-driven paradigm. All games that you've played all have events in them. There might be collisions and triggers. If anyone's ever done any games programming before on Unity or Unreal Engine, all of it relies on events. So we combine them to get the right effects. Jake, you need to forget about Scratch. You need to erase that from your memory. Okay? But there's that point again. There's that point again. It's the elimination of the need to remember syntax to give more focus on the logic of a problem. Okay? Now, here, all of these things have something in common. You might remember some of these from the past. Some of these are from my past. A long time ago. Kevin probably recognizes one from there. It's probably Mario, maybe Crash Bandicoot, but hey, classics. Some classics in there. Got some modern ones and some not so modern ones. Now all of these things, all of them have something in common, and that is that they are triggered by events. You cannot access these games without using events from the user. So you need to take an input from the user and then produce an action or a result based on it. So let's look at event driven then. They rely heavily on user interaction, which will normally be written using an event driven paradigm. And the program will sit in a loop. Now this loop is an infinite loop continually listing out for a user interaction. So think about your computer, think about your keyboard. It sits in an infinite loop. Your operating system is using an event-driven process in order to continually wait for you to interact with your operating system. And it's the same thing. With an event of a user, it could be a key press to move up, down, left or right. It could be the WASD keys. It could be waiting for a combination of button presses. So when the action occurs, when you press the right combination of keys, it will action a function, and that function is called a listener. Also, it can be referred to as an event. When the event's triggered, we just fire the code and run whatever we need to. Very customizable. And in VB, if you want to practice this, you can go and find some code online that will allow you to program individual buttons, create events for individual key presses. And that's the good thing about VB. It is very visual and very event driven. So you've got the drag and drop front end, you've got the back programming end, and you've got all the events in between. So if you look at this diagram explains what happens and how the operating system generates those events. So the user will press a key, the operating system informs the program that the keys have been pressed, and the operating system then sends the event to the application's event queue. What that means is it just goes into a queue and waits to be processed. We work out what code needs to be actioned because of the keys that they've pressed, and then we just run that on key press event or the on mouse click event or whatever input device they're using. Now the good thing about this is that developers, they are responsible for creating all the events. So back in the early Windows days, Bill Gates was hard programming all of these events so that you can enjoy Windows as it is today. So there we are. Developers can all have a go at programming those. You're welcome, AR. Kevin, I don't know if you know these people. I don't know any of them because I don't teach any AS. So, yeah. Welcome, everyone. Everybody's welcome here. Now, if you think about the events and how they all work and things like that, the key presses that go on. Oh, Alex teaches you. Alex and Kevin. Okay. The event processor sits in a nested loop and it continually goes round waiting for the buttons to be pressed. And it's simple. It's as simple as if or select case statements, and the buttons get pressed, we generate actions. So if the A key is pressed, move the character left. If the D key is pressed, move the character to the right. But that infinite loop is important, and it works alongside your operating system as well. Okay, but I won't talk about operating systems and the fact they generate events and interrupt service routines because that is second year content. And if you make it to the second year, I'm sure I'll just explain that to you. Now then, thinking about event driven, I said before Python was a procedural language. It goes in order. Python can also be event driven as well. Why? Because you can import packages into Python to make it event driven, such as Tkinter packages. Java is event driven, and in the top right hand corner I ask my students every year, what is that language in the top right hand corner? Does anyone know what that is? Surprises me the answer every time. Wonder if the AS students are any better. Does anyone know what that language is in the top right hand corner? Don't say infinity. It is Visual Studio. Yeah. Visual Studio. So the it's actually a symbol for the IDE rather than the language. But you've got Visual Studio now. Visual Studio 2022 is out. We used 2019 in college, but we were using 2012 before that. So there we are. Now then, event-driven programming requires the developer not only to think of their code in a linear fashion, but rather a set of actions triggered by the user. So you don't think of it like going from top to bottom in a serial or linear fashion. You think of it as little containers, and the containers get called and we run little modules of code as and when we need them, and that makes reusable code, it makes code a lot more reusable, should I say. So they don't go in order, and the listener functions, or the procedures that you create for event-driven programming, they don't run one after another in your code. They only run when you call them, when you trigger them. And I've said this before, graphic user interfaces, games, etc. will always make use of event-driven programming paradigms. This is not the OCR board. This is the WJEC Educast exam board. Maybe I should move into OCR. I should start doing lessons for OCR as well. Turns out a lot of people are on that. Now, it's fairly common for modern languages to offer some sort of event processing, whether that means importing it into the language like Python does to then use it, because the reason why we create software really nowadays is for an end user, okay, unless it's a batch or an automated system. So there's event-driven in a nutshell. The next one we're talking about is markup languages. Now, if you get asked to talk about markup languages in your exam, you should immediately be thinking about HTML, hypertext, markup language, XML, extensible markup language. Okay? Now, with HTML, I'm just reading the comments. With HTML, it is not a programming language. People say this to me all the time, okay? And in university, there's a big rivalry between the web developers and the actual computer scientists, because we believe that they're not actually programmers, okay? Now, you can add different things into HTML to make it more programmer-like JavaScript, for example, or PHP, but it's a markup language, not a programming language. Its job is to turn plain text into some kind of display, okay? So markup languages are not explicitly a programming paradigm, but they are prevalent in web technologies. So markup languages, they add commands or markup to text documents to offer meaning to the text. Now, you might have done this in secondary school, because a lot of people do. You don't need much software to actually do this. All you need is a web browser, really, and a text file. But the commands give instructions to the program. Now, it reads it and interprets it in the actual browser itself. Okay, so your browser turns the markup language uses hypertext markup language to turn it into a web page itself. Okay, but the browser has to detect the file as a HTML file. So if you look there, if we add commands, what kind of commands are we looking at? So in an exam, make sure that you use examples. So if you look here, you'll see that all the commands that are in blue are surrounded by chevrons. Okay, they're not less than and greater than symbols, they are chevrons. And then closing tags have a slash built within them. Okay, so that means that you've closed the tag. So you start with an open tag and you close it at the end. A couple of different parts to the web page itself. You have the head, you have the body, and then you have the opening HTML tag and the closing one. So the commands in HTML are known as tags, and they're surrounded by chevrons. And commands are opened, for example, H1, that's a header tag, so it displays a header in a web page. So everything that's inside of H1 will display as a header. Commands are then ended with a slash inside, like I said before, and then in the above example, the H1 tag will instruct the browser that the text, "This is my web page," should be displayed as a heading. Now those things, just by talking about the body, the H1 tags, the paragraph tags in here, these are paragraph tags, you can go on W3C Schools and you can find all the different types of tags. Now you're not going to need to explain all the tags in your exam, but you might want to refer to things like paragraph tags, H1 header tags, bodies and heads. Just a couple of those and you'll be on the mark scheme, no problem. Now if you can't remember anything about HTML, you can also talk about XML as well. So if you've never heard of XML or extensible markup language, it is also another markup language, but it's used in web applications. So a web page is just for display really, and a web application is where it actually does some processing in the browser. So XML really is used for storage and structuring data rather than display. So your HTML is for display and your XML is for structuring and storage of data. It looks very similar. It's very customizable. You can make your own commands in it, make your own tags, specify your own meaning, and off you go. So for example there, you would declare your version of XML you're using, and then you can make your own tags. So there's no such thing as a news tag in HTML, but in XML you can make up your own tags to do whatever you like. So just to push the point, the difference between XML and HTML is the fact that XML is designed to carry data and HTML is designed to display it. Now it's a shame in the AS and A2 specification there's no major focus on web technologies and creating web pages. However, if people are interested in web development and web building, then by all means get in touch. We've got lots of resources because we teach it on other courses. I'm sure to help you out if you want to create your own website. Now these markup languages that I've talked about, both HTML and XML, they can be combined with other languages, and you've probably heard of some of these before. JavaScript, for example, or CSS. You don't need to know the difference. No, you'll probably get asked about one to explain markup languages. So you could pick either or and explain some of the characteristics of XML or HTML for exam questions. PHP is a programming language. It's used to put actions on web pages. You'll have to email me, Matib, directly. So HTML displays web pages, JavaScript adds functionality to your web pages, and CSS is for styling, cascading style sheets. And they're all got different versions, so they're continually being updated, and you add them all together for a full package. Now, if you've ever heard of the term full stack developer, then that means that you're working on the front end and also you're working on everything in between, all the way to the back end where databases are, and etc, etc. So you can be a full stack developer. It means you can do everything. You tend to get paid a bit more. So there we are. Now, the last thing I will touch on, but this is really pushing into A2 now, we have something called non-procedural languages. Now the reason why I'm talking about this is because it's very relevant in today's world. Now non-procedural languages, they came from, they're originally from relational databases. Okay, so relational databases are controlled, or they communicate using something called structured query language. We write structured query language and it interrogates the database and returns data for us. All right, now the point of non-procedural languages is that the result, what comes out of the query, is more important than the actual steps to solve the problem. We don't care about the steps. Non-procedural language works the steps out for itself. So you might say, this is machine learning, this is artificial intelligence, and you'd be right in saying that. So non-procedural languages are left to work out the best path or the best solution. So users concentrate on defining the inputs and the outputs rather than the steps, and the rest is all done by the computer itself. So there's a focus on rules, queries and facts, and off it goes. So it doesn't require the traditional logic. And finally, it's used in systems such as artificial intelligence, grammar, so grammar packages like Google Translate, things like that, where it has to determine what language is and the style of the language and the handwriting, and then also language applications where there is ambiguity inside there. So language applications are really difficult to program and to write code for because you have 2, 2 and 2 and you don't know which one you're talking about. That's why we use machine learning and artificial intelligence to help us out. Okay, so that ends our principles of programming chapter, and now we look at system and systems analysis. And there's 2 key parts mentioned here. We've got investigation and the analysis stages. So when it boils down to analysis, we're looking really at what is going on inside the software development lifecycle. So taking requirements from the user, having a discussion about it, getting all the way through design, development, investigations, feasibility studies, they're not in order these, by the way, then getting all the way through software development, getting feedback on it, iterating round, doing maintenance and implementation, and then getting all the way back to the start. So the exam board wants us to focus on 2, and that's the investigation here. So analysis is the process of finding out exactly what the system will entail by employing various fact-finding methods. Fact-finding methods. Now the exam board can ask you questions on these because there are loads of them and there's advantages and disadvantages to them all. So it's critically important that the result of the analysis is as complete as it can be, as incorrectly defined requirements can lead to big delays and escalating costs. Your teachers have probably told you about loads of projects that have gone off topic, that have lost out, they've gone over budget, they've gone over time because the requirements were not clearly defined at the start. So 4 main fact-finding methods during analysis. We have observations, questionnaires, document collecting, and interviews. When it comes down to observation, you are literally shadowing and watching how employees use the software and use the system that they currently have. If they don't have software, then what you do is you just watch the clerical process that's going on. They observe employees in their natural environment to see how the business works, and they write down the inputs, they write down the processes, and they write down the outputs. Inputs, outputs, and processes, that's what we're trying to work out. So sometimes some things that we do, especially when they are done every day, are so natural we fail to notice them. When an outsider watches, these common actions can include them in a new system, and even if they were not part of the original problem definition, we can add them in at this stage. So the good thing about observation is that you pick up parts of the system that are not immediately obvious to the customer, and you can confirm information gathered through different fact-finding methods. The problem with observation is that some people may feel threatened while being watched. I don't know if you've ever seen this, but if you ever see a teacher being observed, they might behave slightly differently, potentially. So there's no guarantee that some of the more subtle parts of the system will show up during the observation period, because you might only be able to nip in for an hour, you might only be able to nip in for 2 hours, you can't stay there all day, you can't watch all the processes going on, you can't be there while there's a big order, for example. So yeah. Questionnaires. Quite common method of fact finding, but can also be one of the most difficult. It is, believe it or not, it is very difficult to produce a solid questionnaire. I did an entire module at university on creating questionnaires. What a time to be alive. So designing a questionnaire requires knowledge of the system to be built and the range of people to whom the questionnaire can be sent to. Are you giving it out on paper? Are you emailing it out to them? This prior knowledge is essential so that questionnaires or questions on the questionnaire can be targeted. Are you doing them for technical users? Are you doing them for non-technical users? So the questions would be different. Are you having open and closed questions? It's also important to restrict the number of choices available for each question, as some people may give unexpected responses. And this means that questionnaires can only give a limited amount of information about very specific parts of the system. So let's have a look then. Let's have a look at the advantages and disadvantages. So the good thing about questionnaires is that they can be given out to a large number of people at once. Think of a Google form, email it out. I can email you out a Google form to the entire year group, dead easy. Problem is, you don't all respond to it because you're all lazy. So there we are. So you can get a large number of different opinions, but it's hard to create and design, and not all questions sent out will be completed. It's just like homework, isn't it? Yeah, when Kevin sets homework, how many people do it? And then he has to come and shout at you and get you to do it. Now, document collection. Whenever document collection is discussed, I always think of a load of old biddies sat in an office collecting documents. But it's not too dissimilar to what we do. We get all the documents that show the analysis, how the business or how the actual organization works, so we can work out and define the inputs, the outputs, and the processes that need to occur to get there. So these include orders such as invoices, financial records, and any other document that are in use on a day-to-day basis. So you can have lots of different documents to look through, and this does take time. So documents in use in the current system are a good guide to what is required in the new system. And the good thing about documents is they don't lie. You can't make them up. Well, you can make them up, but people tend not to because that's called fraud. So some key elements which could be inferred from the analysis of existing documents are the data they use and what will be need to be stored by the new system. The analyst can get a very good understanding of the business process by following the trail of documents and seeing the flow of data from start to finish. Had 11 students who could not be bothered doing the homework set yesterday as I was not in. Some haven't completed it now. Wow. And we're not even far away from the exam, are we, Kevin? You can give me a list of names, Kevin. I'll find them. I'll hunt them down. Because Kevin don't work Fridays. Document collection. One advantage of document collecting is that documents cannot lie, distort, or misrepresent information. This means that the information found in them can be trusted unless someone has purposely gone out their way to doctor the documents. And why would they do that? They're asking for a system to be made. Of course, they don't give a complete picture, but they help support whatever picture the analyst has already built up. And they also help the analyst build up a data dictionary. However, it's not always obvious how, why, or even when a document was created. So there we are. They are reliable. They help support the picture of what's already known. They can give a limited view. You might not be able to see everything and how it's all tied together, but some documents, especially for government organisations, they contain sensitive information, and you often get redacted documents, and that's documents with like big black lines on it where you can't see what the hell is going on. And then finally, data representation. I did data representation in the first one. You can go back and have a look at data representation in the first live stream. We've got interview. There he is, the orange peel, Donald Trump. So interviewing. Nobody likes being interviewed. Well, some people do, but they're psychopaths. Interviewing is normally where most analysts start, okay? They pick a few key stakeholders because they're paying for the system, and then they ask specific targeted questions. So specific targeted questions. And the good thing about asking a question is that you get a response, and then you can ask a follow-up question. And with the other types of techniques that we've looked at, you can't ask follow-up questions unless you're observing, only asking questions, but you're only observing, you're not asking questions. So a lot of information can be gathered in a very short space of time. However, you can have an interview that lasts a very long time. All right? Depends on your interview. But depending on the interviewer or the interviewee, it can be difficult to schedule, time consuming. You can try and interview multiple people. There can be discussions. You can go off task, off topic, for example. So there is a few problems in there. So human nature plays a major role. Not everybody's good at being interviews, and they can't articulate themselves very well. Okay? They also exaggerate. They try to impress, especially Donald Trump, and they'll say how great things are when it's not actually true. So can you trust what's being said? Who knows? So the good thing is you can get large amounts of information. You get very detailed responses. Normally, the analyst will record the interview rather than type it. Then they'll go back and analyze it later. It is time consuming, depending on how many people you're interviewing. So you can only interview a limited number of people. So interviews, so I'm just reading the chat here. Interviews are costly and not really worthwhile for large-scale businesses, unlike smaller businesses who specialise in a small area, such as a local community, and get few repeat customers to do it. I suppose you're right. Interviewees may not be fully truthful, so their responses may need to be verified. Some people may also not know the answers, so you need to make sure you pick the right person to interview. And you would never just do one interview on its own, unless it's a very small business. I can post the video later on. So here, the final one, the need for different types of software systems and their attributes. Two things to cover: types of software. So types of software are open source, bespoke, and the third one off the top of my head is off the shelf. There we go. I had a minor mind melt then. And then we've got expert systems. 4 parts to expert systems. You've got the knowledge base, the inference engine, you have the rule base, and then you have the graphic user interface. 4 parts. So if you didn't get that, rewind the video. Okay, here we go. Last bit now, people. 3 types of software. Now we need to know the characteristics of these and the advantages and disadvantages of them. Now you might be asked in the exam board, you might be asked about why you would choose one over the other. Okay, if this was a typical large mark question, so you normally get a 10 marker at the end of your paper, if you got a 10 marker asking about these, you would normally have to compare and contrast them, or you might get a scenario where it says there is a company and this company is looking for a solution, explain which one would be beneficial. Okay, so bear that in mind. So open source, so all the software on the right hand side there, if you recognize any of those, they are all open source, which means anybody can freely download them. They are publicly accessible. Anybody can modify them if you want to. So open source is a part of the open source initiative, and that is a collaborative space where we are trying to advance the industry of computer science. Anyone can have access, anybody can have a go and use them. So nobody can make money out of them. Anyone can see them, they can modify them, and they can distribute the code as they see fit. And I think one of the most famous examples is Linux and the Linux kernel, which makes operating systems, mobile phone operating systems. Fantastic piece of kit, fantastic piece of code, should I say. And you can modify that any way you want if you've got the know-how. And because it's so collaborative, experts from all over the world can modify and edit and sort the code out. And it's all online. Download it. You can go now and download it. Download different pieces of code if you want. Well, interesting about WordPress. If you do a little bit of research into WordPress, Max, because it backs lots of different websites, something happened with WordPress. And off the top of my head, I think they moved to a paid subscription service. So they used a bit of open source and applied a top coat onto it, if that makes sense. So with open source software, it's the point of it being open source is to encourage development. Now you might have heard the word decentralized, and you're probably thinking cryptocurrency being decentralized, and that's true because it's not owned by a central bank, or it's not managed by a central bank. And it's the same. Open source software is not managed by a central person or a set of people. We have a main code base, and then people create branches from the main code base and edit it as they go. The development relies on peer review and a community production, and no one person owns the rights to the software that's been created. Open source software is often cheaper, more flexible, and has more longevity than its proprietary peers because it's developed by communities rather than a single author or company. If I created a specific or bespoke piece of software, that might have a shelf life. Who knows? How long will Cedar last, for example? How long will your app that you got commissioned last? It'll only last as long as your business or as long as it's fit for purpose. But with open source software, we just adapt it, mold it, modify it, and then we move on. Someone can tell me how long Linux has been around, because it's probably longer than me. It's not as long as Kevin though. So there we are. Now, open source software, did a quick Google search, the top 10. You got browsers, VLC media player, Blender. I don't know if Sam Gregson's still on, but Sam Gregson's just got a job. An ex-student of ours got a job as a Blender person, making things in Blender. What kind of a job's that? Good luck, Sam, on your new job. And then we've got, I think that's, is it GIMP? Is that what it's called? It's like a knockoff Paint. And then you've got all of your packages. Now, Kevin swears by the LibreOffice packages. They're like a knockoff Microsoft Office. 1991, so it is older than me because I was born in 1992. So there you go, I was correct. Now in your exam, it's important that you don't mention specific brands. Okay? If you're going to talk about different software, you can talk about graphics packages. That's generic. You can talk about word processing applications. You can talk about spreadsheet calculation software, right? But don't mention specific brands because you are saying that the examiner knows what you're talking about when it comes to that. For the advanced info, do we need to mainly learn the subtopic chapter, fetch, decode, execute cycle from hardware communication, or is it we need to learn the whole chapter? You focus on the amplification, so the subtopics first, okay? Get those, nail those ones, and then I would do some revision of the chapter itself, because like you said before, low tariff, low mark questions are also going to appear in different chapters, okay? So bear that in mind. See, Kevin? So bespoke software is very, very expensive. That's the first thing that you're going to be writing in your exam. See, Kevin? Thank you very much for coming. So bespoke software is very expensive, and it is custom and tailor-made. The reason why it is expensive is because it perfectly matches the specification. You say exactly what you want, and it gets exactly made to that. So because of that, it takes a lot of time to develop. It requires a lot of testing, and that obviously has to be paid for. So bespoke software is custom tailor-made software. Now, because of it being bespoke, it has a very specific set of requirements that it needs to meet. And normally, it's made for safety critical systems, and that's things like real-time control systems. Real-time control. That's things that there's a risk to life, like nuclear power stations, autopilot systems, air traffic control systems. They are bespoke pieces of software. You won't go to Curry's PC World and buy air traffic control version 1 off the shelf and then plug it in and go, right, we're going to fly everything out of Manchester Airport, because that would not be safe, okay? So we use bespoke software. Now, it's custom, users need it, it's down to the user's needs. It will need to be thoroughly designed, developed and tested, and due to the development process and the time taken, bespoke software is the most expensive of all software in the market. Now think about CEDA. CEDA, our MIS system that we use, CEDA, that was a bespoke piece of software. It was made for Cardinal Newman College. They have an in-house software developer. They make the software to their specification, and then they realized, you know what, this is all right. We could package this up and we could sell it. So they did. So then it moved from a bespoke piece of software to an off-the-shelf piece of software. So my question to you is, why might someone want to commission a bespoke piece of software if it's so expensive? And the reason why is because they might want a new innovative product that doesn't exist, or makes use of new technology that doesn't exist. They might want the software to exactly match their business processes. They might want their customers to have a unique experience. They might find, or they might not be able to find, off-the-shelf products that fit, like GCHQ and security firms and MI5, etc. All that down there. And also, they need to interrogate the software with other third-party. They need to integrate it. So they need to fix and mold them all together, and they might need a bespoke piece of software for that. Okay, so you might have seen some bespoke software out there. You've definitely used bespoke software, and I just think all the apps that you download or the websites you use, they have been made for a specific purpose. Things like Amazon, Airbnb, McDonald's, website or app, doesn't matter, Uber Eats, TikTok. Yeah, they have specific purposes, and they were, or where they are, the top 5 bespoke software packages apparently, according to Google, circa 2020. 2022, what I'm talking about, 2 years behind. So, finally, off-the-shelf software. And here he is, our mate, who made Microsoft Office. Big Bill. Now, off-the-shelf is also called commercial software because it gets designed for a generic set of reasons and it's developed for the mass market. It tries to hit as many needs as possible. And then the cost of making it is then spread between all the users. So therefore, it's not as expensive as bespoke. It's not as cheap as open source, but it's a good middle ground. And Bill Gates is obviously one of the most famous off-the-shelf software creators of all time. That's how he made his fortune, followed by operating systems, etc., etc. You can use proprietary software. Yep, that's okay. You can use that. I just like to think of off the shelf because that's what goes on in my head. When I buy it, I go to Curry's PC World and I will get it off the shelf. That's how we used to do it anyway before the time of digital downloads. We used to actually have these things called CDs, compact discs, and we used to put them in and install software. Look at your laptop. Does it have a CD drive? Probably not. Shame Kevin's gone because we could have talked about floppy disk drives, but you know, thing of the past. So off the shelf, I don't know why Adobe has so much software, by the way. Does anyone know what Adobe Spark does, or Prelude, or InCopy, or Fuse? I have no idea at all. Why have they got so much software? And why is it so expensive? And don't torrent these, by the way. Yeah, get an Adobe Creative license, you illegal people. So if with off-the-shelf software, there's an initial cost. Okay, you create the cost. It all does the same thing. They just make money, pretty much. Yeah, incriminating evidence. This is all evidence. This, I'll report you. See, I can use this software as an educator. So there we are. So with off-the-shelf software, there's initial cost, and we spread the cost out across the millions of users. So they price it at a point where they have to make a threshold, and then everything after that is profit. So the good thing is we all share the cost. So the benefit to this is it's cheaper for the users, but the drawback is it's not a custom solution for your needs. So think about mass-produced software. Adobe was greedy. When I was in university, they were charging like £400 for Adobe Photoshop. I was like, nope. Nope. All right, last thing then, people. Last thing. Expert systems. Have you used an expert system before? I guarantee it. I guarantee it. Have you ever been on a website and it's offered you a chat function where it pops up and it says, hiya, welcome to, again, PC World of Currys. Let's talk about a product or something. And you start talking and it's like, wow, this is a very robotic response. That's an expert system. You put in questions and it gives you the answer. Akinator. I was using Akinator. I was teaching expert systems the other day, and Akinator, I used it. If you don't know what it is, it guessed my answer twice. And the animals I put in there were well obscure. Somebody put the link in the chat. It blew my mind. Akinator is an expert system, a very, very good one. Here's another one. Symptom Mate. So at the moment I've got a cold, so you might hear me a bit nasally. So Symptom Mate basically works out whether you are going to die or not. So there, when I put in all my symptoms, call an ambulance. Chest pain, blood oxygen level low, chest pain spreading between the shoulder blades, severe chest pain. I need to call an ambulance right now. No, I put my actual symptoms in. It said I've got a cold. So don't worry, people. Don't worry. I'm fine. I'm fine. If you make it to next year, I'll probably teach you. So expert systems are also known as KBS, or knowledge-based systems. All right. It's a piece of software. You put in your questions. It gives you questions. You put in your answers, and it works out based on that what is going on. It uses a backend database, and the backend database then infers what you're saying and tries to give you an answer. Now, there's three situations that we have. The expert system will either go, yep, I know what the problem is with you, there's your answer. Or it'll go, actually, I don't quite know what's going on with you. I'll ask you some more questions so we can get towards a more accurate answer. Or the third option is it'll go, I've asked you more questions, but I still don't have a clue. Sorry, I cannot give you a proper answer. So there's three options. Give me the answer because it's confident. It's not confident, ask more questions. It's not confident at all, even after questions. And therefore, we can't give you an answer. So this is the process. System, user interrogates vast knowledge base to find a solution. The user enters the information they already have, and then it infers the answer. If the system can't reach a conclusion, it requests more information by asking more questions. The process is continued until the system has what we call a high degree of confidence. So it works out a number, and if it's got a high degree of confidence and it meets the threshold, it will give you a solution to what it thinks it is. Now there are there's technically three key parts, but you need four in order for it to be a complete system. So the four key parts are, you've got a knowledge base, you've got the inference engine, the rule base, and then the user interface. So they're the four parts. The three main ones are knowledge base, inference engine, and rule base. You talk about those three, you're going to hit the mark scheme all day long. Knowledge base, that's where all your knowledge goes into from your experts. If it was a medical system, who would your experts be? They'd be general practitioners, there'd be actual surgeons, doctors, specialists, consultants, blah 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 blah. Inference engine, we infer the answer. We work out the degree of confidence in the inference engine by applying what you've said to the rule base. The rule base is the rules. It's just basically a load of if statements. If I have a runny nose, if I have a sore throat, and if I have a headache, I've probably got a cold. If, cold. The user interface is how I interact with the system. So the knowledge base then has all the expert knowledge. We pour as much information as we can in. And the benefit to doing that is once all the information's in there, it can be easily updated because it's electronic. It's a database. We can update it if things change. So that all gets put in. It can be added to from across the world. Experts, leading experts from all over the place can add information in. And it gets stored as if-then statements. So selection statements. After that, the inference engine applies the rules to known facts. So the rules from the rule base to the answers we've given, and it deduces what's going on there. So it attempts to work out the answer to the user's query by using the rule base. So to infer something is to make a decision based on facts. So if the user has said they have a runny nose, if the user has said they feel tired, if the user has said they have a headache, if the user has said they've got dry mouth because they've been on a live stream for hours, then they're probably a computer science teacher. And they've also got a cold. So the inference engine has those three options. And the three options are, we've got enough information, output the result, haven't got enough information, ask more questions, or we can't get to a decision. That's what those three things in red say. I've just summarised it for you. Okay, just give you a second to read those. That's right. I'm going to put a Patreon link in the chat so you can all donate money. I'm joking, I can't do that. Like and subscribe, very important. So just give that a read. Now, we've got our rule base next. So our rule base, John has no morals. Legally or morally can't. I don't know. Technically, this YouTube channel is not linked to college. It's JB Computer Science. So technically I could, but I think it's like morally not correct. Okay, so the rule base that links the knowledge together through facts. The system works out the degree of certainty by applying the rule base to the user's inputs. Now, things like Akinator that we're talking about before and these expert systems is that they actually learn. Modern expert systems learn through machine learning. Okay, machine learning helps us deduce these things, update the rule base based on what people are saying. So if we get the wrong answer or we get feedback from the user, we update and get the system to learn from that in the rule base. So the rule base is all about the degree of certainty. So if the degree of certainty is high, then the system provides the answer. If not, more questions to try and get a higher degree of certainty. If we can't meet the threshold and it's inconclusive, we don't give a decision. We don't make a decision. We don't give a diagnosis, for example. So I'm trying to think for you a couple of different expert systems. So there might be things like mortgage applications, bank loan decisions, It might be medical systems. It could be as simple as a mechanic diagnostic piece of software or something like that that works out lots of complex decisions based on faults, for example. Okay, there's lots of them. So the last one, user interface. The user's going to have to be able to interface with the system. Okay, they're going to have to. So HCI stands for Human Computer Interface, and that is how the user interacts with what they're seeing in front of them. And normally it's a graphic user interface, isn't it? Because that's the way we interact nowadays. It's not going to be a command line interface with text, because that's not very fun, and we want the users to actually use it. So here we are. The user will use the user interface, and they will put their query in, and they'll get their advice out. Why might we use expert systems? Because these guys, draw a little face on it. Okay, these people are very, very expensive. Dollar bills. Okay, we want to stop. The NHS is overrun already as it is. We haven't got time to diagnose everybody because they've got cat scratches and like a poorly shoulder or something like that. So we have to work and use technology as an advantage. So if we can get rid of GPs or filter like these Karens that exist, okay, if we filter these people, then we don't always send them to the GP. Might be able to just send them back home because they need bed rest, or we might be able to send them to a pharmacist or something like that. So we can use expert systems as a benefit. So let's have a look at some of the benefits then. We've got the knowledge of multiple experts can be stored. We said that. We can send it all around the world. Oh, wow. All right. Thanks, Max. That's a very strong opinion there. Some people might have cats, Max. I don't have cats, but they could. Some people could have cats and they might get offended by that comment. Maybe I'll report you to YouTube. I don't know. I'll think about it. So knowledge of multiple experts can be stored in a database. And years and vast amounts of information can be stored. So the knowledge base, the database itself, can be updated digitally, dead easy, all the time. And think about computer systems versus humans. Okay? Humans, let's be honest, humans are pretty pathetic. Okay? They get tired. They can hold lots of information, but they can't hold everything in their head. They make mistakes. They can't work all the time. We have to pay them a pension. We have to pay them wages. No, just humans, no. So what happens with these is they are available 24/7. They don't get sick. They don't take days off, these expert systems. You can use them whenever you want. They are used to reduce labour costs. So, yeah, humans are getting sacked slowly in order to replace them with computers, which is fine. It allows access to professionals where one isn't available. So think about remote areas. So think about a small village that doesn't have a doctor. We could allow someone to use the expert system, and then it says, you know what, you need to send this person to hospital. Then we send them on to hospital. Also encourages better use of time for experts. So you don't have GPs on like £80,000 a year going, yeah, you just need paracetamol and go to sleep. What a waste of money. So we make better use of time. And very good expert systems, they will explain the outcome of the decision. So they will say, oh, actually, you've got a cold, but you might have acute sinusitis. And it will give you a percentage. It'll say 89% we think is a common cold. We think 50% it could be sinusitis or something like that. Expert systems make use of machine learning. We talked about that one. So they are your benefits. Happy days. Benefits of expert systems. So it might be dead straightforward to answer a question then like this. State what is meant by the term expert system. It's only worth 2 marks. So I would simply go in there and go, well, what does it have? An expert system has a knowledge base, which is populated by experts from all over the place. It also has an inference engine which makes decisions based on a degree of confidence. Inference engine. And our third one we could even talk about, I've already got 2 marks by the way, but we could go on and we could say, well, it also has the knowledge base. No, not knowledge base, what I'm talking about. It has the rule base. You could talk about those. Stop doing that. There we go. So yeah, what is meant by the term expert system? It's a system that asks questions, you get answers, you make decisions based on rules, based on the knowledge that's in the database. Maximum number of marks for expert system questions. Well, Matib, this is the most modern expert system question that I could find. So I couldn't put an exact number on it, but this is 8 marks, this question set. So yeah, couldn't put a number on it. 6/12. I think there might be a 10 one knocking around. 10 mark question. Now for an expert system which you have studied, so normally I recommend students to go down the medical route. Just makes the most sense to me because it's such a specialised field, okay? But you could talk about medical. I said a few others before. Things like careers. And that could be careers advice. The only reason I'm saying that one is because I remember I used an expert system in year 9 that you put in all the things that you enjoy doing, and then it comes up with the career that you should have. And you probably won't be able to guess the career that was worked out for me. And it wasn't a teacher, believe it or not. It wasn't a teacher. The career that came out for me was a golf greenkeeper. So cutting grass on a golf course. There we are. Who'd have thought it? Yeah, that was a good expert system, wasn't it? Also, you've got diagnostics in car faults. Car faults. There's loads you could have. I said insurance before. I also said you could have mortgage or loan. Loans, etc, etc. Okay, maybe when I'm old enough I'll go back to golf greenkeeping. Who knows? Now it says describe how it is used and discuss the benefits. So how is it used? So you might say questions are asked first. So questions are asked. Input from the user. I'm being very brief here. You would obviously write this in full sentences. Questions asked. Input from the user. And then we process. So we process the facts against the rules. And with the facts, when you say you're processing the facts, you'd say the facts come from the knowledge base. So you'd explain your process again, you'd explain your knowledge base, you'd explain your inference engine and your rule base being involved and how they all link together. Okay, with the 6 marks, because you've got 6 marks in each one of these 3 stages, you'd say you talk about the fact that it's a database of knowledge, and then you could slip in there a benefit in there as well. So because it's a database of knowledge, you could say it's electronic, so it's updated easily. Okay, so you see what I'm doing here? I'm stating my point that I know about the different parts. I am then explaining how that works, and then I'm slipping in a benefit alongside that. And if you do 2 of them, 1 mark, 1 mark, 1 mark, It's only worth 6. So you're not, you're going to be able to hit all of them pretty easily. Hopefully that's nice and clear for you. That was clear as custard. If I show you the mark scheme, then I'll just show you the mark scheme. I mean, this one, what is meant by a term expert system: 1 mark for each of the following, up to a maximum of 2. So I talked about all of them. Did I talk about that one? I didn't talk about that, I don't think. Level of confidence, I didn't even need them. So that was fine. I think I got 2 marks for that. 1 mark for each of the points below, up to a maximum of 6. 2 marks maximum for advantages. So you only get 2 for the advantages. Benefits, 2 marks. The question that you might be asking is, how the hell do you know that? And it's a great question. How do they just decide that 2 marks maximum for advantages? There you go. Hopefully, though, in your discussion, you would have covered all of these points regardless, or most of them. So there you go. Medical diagnosis, careers, diagnostics, car faults, insurance. Oh, bank loan. There you go. Mortgage. So input stage, providing a sequence of questions on. So inputs, we talked about inputs, I'm sure we did. Inputs. Explain the processing stage. Asks different questions depending on responses until sufficient. So we should have said that it keeps asking questions until it reaches a degree of confidence. And degree of confidence is down here. Degree of certainty. So I could have linked them two together. Okay. Processes the facts according to a set of rules. Said that. Explaining the output stage, diagnosis and treatment advice. So I didn't say anything about outputs, but I should have done. I think I got all the 6 marks without saying that though. The program comments on how the conclusion was reached. So remember, a good expert system will explain its decision. And then we've got some advantages. Faster, more consistent loan applications, more accurate medical diagnosis, less chance of systems being overlooked. So you link that back to the expert system that you have studied. Okay. And there's an 8 marker on that. But I'll send this out and it's already got the information attached. Okay, so everything in there that we've been through. Does anyone have any questions about any of the stuff in there? We've been going for 1 hour and 43 minutes. In total, that's nearly a 4-hour stream. I'll hang on for some questions, but people, what's a con of expert systems? They take a long time to actually get a good knowledge base. They still can be inaccurate. I mean, you could argue causing unemployment, is that necessarily a bad thing? Nah. You could argue both sides of that point. As long as you justify and give reasons for that, you'll be absolutely fine. Because you can justify your point. What is the most important topics you need to do? If you're talking about, if you're a student at my college, I don't know if you are or not, but if you're a student at my college, then those on screen are the main ones that you need to focus on. Those are the main ones. Are there any subject-specific exam-style questions? Yes, there are. When you say subject-specific, what are you talking about? But there are lots of exam-style questions for these topics. So what I would do is, if not already, your teacher, they have access to a document called All Exam Questions Sorted. Okay? And that shows all the exam questions. Kevin built it. There's one for A2 that I built as well. My A2 one has mark schemes embedded. But if you ask your teacher for the all exam questions sorted document, they'll give you a copy of that, and that's all linked by chapter. So all the questions are in topics. We got papers on Tuesday. Yep. If you haven't got access to papers or you missed that lesson, judging by what Max has said, you can go on Google Sites. Your college card, I think it has like 30 quid on it, where you can just spend for printing. That's assigned to you. I believe that's still the case. Or just ask your teacher to print some off. Is it £10? Oh man, budget cuts. Used to be £30 when I was a student. Actually, it was unlimited when I was a student at Oldham Sixth Form. What? Like a bank of questions. Yeah, Matib, yeah, it is. It's a document. That is a bank of questions. It's exactly like that. I'll show you what it looks like. I'll show you what... Should I find it? Yeah, I'll find it. So there we go, I've found it, and this is what it looks like. Wow, that is slow. So for example, yeah, you've got all your topics by chapter, and then just click on it and it'll take you to the area. And each one of them is like banded in a topic. And they're all in there, all the exam questions. And for A2, second year, they have their own, if it ever loads. So I've converted that to a newer Google Doc, and I've kept on top of it. So I've added the 2020, 2021 exam questions, all by topics. These topics are different. They look different because they are, in the second year, you get the same topics, but they're banded differently. So they've got different numbers and stuff. So for example, if I wanted operating system questions in component 2, you go down there and then it jumps to it and it shows you the exam questions if it loads and actually takes me to it. Why is it so slow? Who's killing my internet? Does that exist? What? Where do you access this? You ask your tutor for it and they'll put it on Google Classroom. Max, yeah, anything like... What are you on about? I don't even know what that means. I've never even heard of that. Is that a piece of software? What is it? Website? Okay, people. Oh, my internet. What is happening? Is there like any interactive websites or revisions basically? You know what? There's something called Isaac Computing. I don't know if it's interactive, but it's very good. It's probably the best one I've seen. Isaac Computing. And you make an account and they do online classes for you as well if you're struggling in certain topics. But it's very, very good. It says my stream status is poor here, people. I don't know if you can still hear me or you can still see me. But if you're hanging around, that's absolutely fine. But I just want to say thank you very much for attending. It's very good of you to spend most of your evening here, and hopefully it pays off for you in your exam. I will be there for your exam, making sure everybody's good. And if you've got any questions or there's still things that you need to sort out, etc., if your teacher's not available, then come and find me. More than happy to go through some stuff. If you want to attend, if you want space to work, that's not the no, head to room 242. That's always space in there available for you. I will find you space to work with computers or laptops in a nice big room at the end of the corridor. Okay? That's fantastic. All right, so thanks very much for coming, people. And I hope you have a great evening. I thought Max was having a moment there for a minute. See you later, people. No problem, Matib. Yes, you have. Might be a computer science room next year. Who knows? See you later. Maybe. Maybe. Only the best people make it into the second year. See you later. See ya. Bye-bye.